Hello, this is just a recording I'm making quickly for the most wonderful class in the world, which is our class. The first thing we're going to be learning in example number 1 is called how to find the determinant of a square of 4 numbers. So the determinant of a square of 4 numbers is indicated by drawing absolute value lines around them, but it does not mean absolute value. It's actually called a special name called the determinant. The determinant, and it's the square of numbers like that is called a matrix. So the determinant of a matrix. What you do is you take the first corner in the top left multiplied by the last corner in the bottom right, and then you subtract the other two corners in the top right times the bottom left. When you take the first and last numbers multiplied together minus the other two numbers multiplied together, you get the result, which is called the determinant. And you get 16 plus 30, which equals 46. So we've now learned how to find the determinant of a square of 4 numbers. Now we're going to use that to do something really exciting. We're going to use that to solve equations without even doing any algebra on them. So here's an example of that. 4x plus 2y equals 8. Wow, 4 plus 4 equals 8. That's so cool. 2x plus 4y equals 28. And 28 is a perfect number, actually. It really is. You can look it up. So 4x plus 2y equals 8. 2x plus 4y equals 28. What we're going to do is we're going to find the determinant of the coefficients of the square of those 4 numbers on the left side. In order to do this, it has to be x first and then y in both equations. So we're going to put those 4 numbers, 4, 2, 2, 4, into those lines. We're going to find the determinant of them. So it's the first corner times the last corner minus the other corners multiplied together. And you get 16 minus 4, which equals 12. Now, what we're going to do is something extremely strange. We're going to look at the numbers on the right side of the original problem. Those numbers right there. We're going to substitute those numbers in place of the numbers that came from the x coefficients. When you do that, you're going to get those two numbers, 8 and 28, in the place of the coefficients of x. The other two numbers in the problem are going to stay the same. When you do this, this is called the determinant of x, or dx for short. So it's 828 and then 2, 4. And then you still do the first corner times the last corner minus the other two corners multiplied together. So you get 32 minus 56, which equals negative 24. And then we're going to do the same thing, but replace the y values with those numbers, those amazing numbers. So we're going to take those numbers right there, substitute them into the original matrix in the place of those numbers where the 2 and the 4 are. So 8 and 28 go in the place of the coefficients of the y values now. And when you do that, and you keep the 4 and the 2 in the same place as before. So when you replace the column of the y coefficients with the right side numbers, but you keep the x coefficients the same as they originally were, this is called the determinant of y, or dy for short. And then you find the determinant by doing the first corner times the last corner minus the other two corners multiplied together. And it's kind of a big number, 112 minus 16 equals 86. No, my fault, 96. 96. Now, the cool thing, the amazing thing is that if you just want to find x, you can just take the determinant of x, or dx for short, divided by the original determinant, and conceptually speaking, the d's cross out, and you'll get x. So dx negative 24 divided by d, 12, equals x, which is negative 2. Whoops, I wrote two negative signs. My fault. So dx divided by d equals negative 24 divided by 12 equals negative 2. And y equals the determinant of y divided by the determinant, which equals 96 divided by 12, which equals 8. So the answer together as an ordered pair, which represents the point where the lines cross each other, the solution is parentheses negative 2 comma 8 with parentheses around it. So that's the solution, and it's sensational. Let's try a couple more examples. So number 3, this one says 7x plus 7y equals 8, and 8x plus 6y equals 14. Sweet. So let's go ahead and find the determinant of the left side square of 4 numbers. 7786, which equals 42 minus 56, which equals negative 14. And then we'll find the determinant of x. So we replace the x coefficients by the right side, 8, 14, in the first column. And by the way, while we're doing that, we might as well do the determinant of y, which is when you replace the y coefficients with the same numbers on the right side. But when you find the determinant of x, you keep the other two numbers the same as they originally were. And when you do the determinant of y, you keep the other two numbers the same as they originally were. So the determinant of x is equal to 48, because it's 8 times 6, first corner times last corner, minus the other two corners, 7 times 14. That'd be 98. So we get negative 50. And then determinant of y, we get 7 times 14, that's 98, minus 8 times 8, that's 64. That's 34. So once again, the x value is equal to the determinant of x divided by the determinant. It's negative 50 divided by negative 14, which reduces by negative 2 to be positive 25 over positive 7. And then y equals the determinant of y divided by the determinant, which equals 34 divided by negative 14, which reduces by 2 again to be 17 over negative 7, or in other words, you could just simply say negative 17 sevenths, because a positive divided by a negative is a negative. So the final solution is just an ordered pair, 25 sevenths, comma, negative 17 sevenths. And notice that even though we got fractions for the answers, we didn't have to deal with any fractions in the solution process, except at the end when we just simplified the fractions. So we basically got all the way to the final answer almost without even having any fractions, which was cool. Now let's solve problem number 4. Example number 4. This one says x equals y plus 6 and x plus y equals 8. So the question first asks, can Cramer's rule be used? Well, Cramer's rule should be used only when the letters are on the left side in alphabetical order, and the numbers on the right. But that doesn't mean that Cramer's rule can't be used in this one. We just simply need to put that letter on the left side. If we move a positive term from the right side to the left side, then it will become a negative term. So x minus y equals 6, and x plus y equals 8. But that alone doesn't necessarily mean that Cramer's rule can be used, because actually, since the process for using Cramer's rule, by the way, this is called Cramer's rule. I didn't tell you that before. This shortcut for solving equations is called Cramer's rule. And when you use Cramer's rule, which says that x equals the determinant of x divided by the determinant, and y equals the determinant of y divided by the determinant, you can only use that if you can divide by the determinant. So this only works if the number in the bottom is not equal to 0. If it is equal to 0, then you cannot use Cramer's rule. So let's find out if it's equal to 0. So the coefficients of these 4 numbers are all invisible because they're all either 1 or negative 1. So let me fill them in for you real quick. The first coefficient is 1, then negative 1, then 1, then positive 1. So it's the first number times the last number minus the other two numbers multiplied together. So 1 times 1 is 1, negative 1 times negative 1 is positive 1. So we get 2. So we can use this rule. So Cramer's rule can be used because we are not going to be dividing by 0. So the answer to part A is that it can be used. Then the answer to part B is to find the solution. So since it can be used, that means that x is equal to dx over d, which is equal to, oh, I didn't find dx yet. So obviously I can't find that yet. I need to find a dx before I can jump to the end. So I take these numbers right here, 6 and 8, and I plug them in where the x values are. And then I plug them in to where the y values are, the y coefficients, I mean. So if I plug 6 and 8 where the x coefficients used to be, and then if I plug 6 and 8 into where the y coefficients used to be, and I'll leave the other numbers the same as they were in the original determinant, then I have found dx for that one and dy for that one. So you do the first number times the last number, 6 times 1, minus the other two numbers multiplied together. And you do the first number times the last number, minus the other two numbers multiplied together. So 6 times 1 is 6, negative negative is a positive 8, and then you get a positive 8 minus 6. So 6 plus 8 is 14. 8 minus 6 is 2. So this means x equals dx divided by d, which is 14 divided by 2, which equals 7, period. And it means that y equals dy divided by d equals 2 divided by 2, which equals 1. So that means if you write the solutions as an ordered pair, the answer, which I'll put in green because it's spring, will be 7 for x and 1 for y. So the solution is the point 7, 1. That is where the lines cross each other. Therefore, it's the solution to the system of equations. And I hope this helps you, and you are amazing and wonderful. God created you, and I believe in you. Thank you very much. You are amazing.